So if I'm going to find the square of a whole number, this side here would be 3 squares, right? And this side here is going to be 3 squares, right? So that would be 3 times 3, and that's going to be equal to 9, right? Because there's 3 squares going this way, going in a row, and there's 3 squares going down. So it's 9 squares. Okay, we can also write this as 3 squared. When we're looking at decimals, what I like to do is I like to square this number first. I know, well, this squared is 0.5, right? Times 0.5. So what I meant by what I said about square this number first is I ignore the decimals. I pretend they're not there, and I just say, hey, what's 5 times 5? And that's 25. Now, if you watch the review videos that I posted, you'll know I have to look at this number first, and I see where the decimal is. So I count that as 1. So I move the decimal over 1 place, right? And then I'm going to look at the next number, and I'm going to move the decimal a 2nd place. And so I know that the decimal is going to go right there. 1 decimal 2, right? 1 and 2/10 squared is going to be written like this. So the first thing I do is I just say, what is 12 times 12? Well, I know that 12 times 12 is 144. Then I do the same thing again as I decimal is, so I know I need to move the decimal over 1 place. And then I look at the decimal on this side, on the second number, and I can move the decimal 1 more place. And I know that the answer would then be 1 and 44 hundredths. Right? Because this last 4 is in the hundredths place. We're going to remember here, when I was looking at 25 and I was trying to find the perfect squares, I would think what times what equals 25, right? And so that would be 5 times 5 is equal to 25. Same as 81. I know that's 9 times 9. And 64, I know that's 8 times 8. But what if I'm trying to find the square root of 13? Okay, so like if I was doing 13, what squared equals 13, right? I know this is not going to be a whole number like 8 is. It is going to have a decimal. We're going to break this into smaller steps. I'm going to have a look at these questions here first. Can I share 10 evenly between 2 people? Absolutely, I can, right? This person gets $5, woohoo, and this person gets $5, fantastic. Same as 14, right? This person is going to get $7 and this person is going to get $7. And I know that they're even. And this, I probably shouldn't do it this way, but I know this is addition, right? This is not multiplication. We are not making factors here. And I can split 20 with my 2 buddies, right? And this buddy is going to get $10 and I'm going to get $10. But what about D? I have $15. And if I compare B and D, $15 is just a little bit more than 14, but it's less than C, right? So it's going to fit somewhere in between there. So I know it's going to be somewhere in between $7 and $10, right? I can actually break that money. So if I had $15, that would be a 10 and a 5, right? I could break it up into smaller dollars, right? So I know that this person, okay, if I'm going to break the 10 up, is going to get a 5 from the 10, and this person's going to get a 5 from the 10, right? Now, I'm going to look at the 5, and half of 5 is going to be $2.50, and $2.50, right? And then I can add them back together. So I know that each person is going to get $7.50. This is not a whole number because it has a decimal. Now, what does this have to do with finding square roots? All right, now I'm going to find the whole number that a square root fits between. So what do I mean? I mean, like on a number line here, where are these non-whole numbers going to fit on the number line in between the different numbers? Okay, so the non-perfect squares, that's what we're looking at. So if I have 13, I know that there's 2 numbers that are going to multiply together to get 13. Just like there's 2 numbers that multiply to get 1, 2 numbers that multiply to get 4, 2 numbers that multiply to get 3, 2 numbers that multiply to get 16, and two numbers that multiply to get 10. So if I'm trying to find the square root of 13, the first thing I need to think about is where does this number fit on the number line? So I'm going to look at this number here, and I know if looking here that it is going to fit in between 3 and 4 on the number line. Okay, because the square root of 16 is 4 and the square root of 9 is 3. So I know it's going to fit in between those two numbers on the number line. It will fit somewhere in there. So I know that it's going to be 3 decimal something. Okay, we're going to get back to this later. If I'm looking at the square root of 8, and I'm trying to figure out where it is between, I can multiply it by the square root of 8, and that's just going to be 8. And I can prove that because the square root of 8 times 8 is 64, and then I can take the square root of that, and that's 8, right? So 8 is between 2 times 2, which is 4, and 3 times 3, which is 9. It's going to fit in between 2 and 3, okay? Now, if you want to double check me on that, you can take the square root of 8 on your calculator. But for right now, let's just stick with this routine. Let's do this again. I am looking for this where the square root of 21 fits on the number line, right? So all I'm going to do is multiply it by its square root, by its same square root, and then I get 21. And I think 21, if I look back, 25 is here and 16 is here. So I know it's going to fit somewhere in between 4 and 5. I know that it's going to fit somewhere between 4 times 4, that is 16, and 5 times 5 is 25. Okay, and then I know that the square root of 21 is going to be between, on the number line, between 4 and 5. So if I go back, it's going to fit in here somewhere. Okay, so right now we're just finding where it fits on the number line. Let's visualize this. Let's take the number 19. And I'm going to look at the square here. That's a 1 by 1 square. That square is right there. Okay, and that is 1 squared, right? This is 2 squared, 3 squared, right? If we look here, okay? And notice how they all kind of fit into each other. So if the number line analogy doesn't work for you, then hopefully this one does. Okay, so that's 3 squared, which is 9, okay? And so now 19, I know would be between 4 and 5 because 4 squared is 16 and 5 squared is 25. Okay, so it's going to fit somewhere in here because 19 fits somewhere in there. Now, if I want to show the perfect square of 19, okay, so this is 9. Here, this is 4, so that would be 16. And this would be 5 because it has 1, 2, 3, 4, 5 squares that way, and 1, 2, 3, 4, 5 squares that way. So this is 5. It's going to fit somewhere in between. It's going to include all of the squares up until this point, right? Because that's 16, 17, 18, 17, 18, 19, right? That does not make a square, does it? But it shows that it's somewhere between 4 and 5, right? So what would that actually look like if I did the actual square? So let's get rid of this. And it would be, the actual square would fit somewhere like this in between. That's what the square would look like. So it shows that there's going to be a decimal. Like if I was going to look at the square root of 11, I can draw it out this way, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 squares, right? But they're not even. So if you look at this representation over here, it shows that it's in between. This is 3 by 3, right? So it's 3 squared. It's in between 3 and 4 because it hasn't filled up those 4 squares, right? So it's somewhere in between, and it will be closer to 3 if we draw the number line. 11 will be closer to 3, somewhere in here, on the number line, than it is to 4.